Welcome. I'm going to talk a little bit about how you can um, maintain or improve your development velocity without compromising security and risk. And, we've all talked about shift left over the years. I think that became a popular mantra back in 2006 or so when NIST did a study to show how you can really save tangible costs if you can shift left. But the challenge is how. It's easier said than done. And even basic application security is rather challenging. Um, it takes a combination of people, processes, and tools. So it's not just a matter of installing an appliance on your network and tuning it uh, occasionally. You really have to orchestrate your people, processes, and tools and get everyone on board to not only care about security, because I did a focus group a while back and found that developers really do care about security, but they're frustrated because they don't feel like they have the tools to empower them to find and fix vulnerabilities. And so this really demonstrates lots of challenges across the board for application security. So the best advice that I have is you've got to think out of the box. You've got to think outside of traditional AppSec tools and traditional AppSec workflows. A lot of people will double down on their mission critical applications and test, whether pen testing, automated testing, to try to find every vulnerability and really focus on that. And in the meantime, they've got this gaping hole somewhere else that may be less obvious. Well, you know what? The attackers know that. They're not going to go directly after the crown jewels. They're going to go through that open window and then traverse laterally across to get to the good stuff. And so you really have to think about protecting yourself on all fronts and scanning all of your code. Now, when you think about scanning all of your code, though, if you're coming at this from a traditional AppSec perspective, it's a little bit like a square peg in a round hole. And how do you fit, a monolithic scan? So I'm going to scan the entire application into a process where that is becoming, agile requires more minimal viable product, minimal viable change, smaller increments of code. Those two kind of hit head on if you're using traditional tools and traditional processes. Now, throw into that one more thing to think about. You've got some new attack surfaces to consider. If you're going down the path of cloud native, you've got containers and orchestrators and microservices. And all of those things represent new attack surfaces that you need to consider. So it's not just the application, but the infrastructure that it relies upon as well. Now, I attend RSA regularly, which is a security conference in the US, and I heard a panelist say, "Oh, I don't have to worry about security because I'm using the cloud, and the cloud service provider takes care of all that." Well, you know what? They don't. It's still your responsibility. There are some things that they take care of, but there's a lot that they don't. And misconfiguration is a huge one. In the past, most attacks happen from failure to patch, and that will continue to be a problem, failure to patch. But I would argue that misconfiguration is going to be second going forward. It's just too hard to consider all the different levers that you have to pull across your cloud service provider, your containers, your orchestrators like Kubernetes, and your application environment. And so you've got to think differently. And let's talk a little bit about how to do that. When you think about, Sarah mentioned monolithics, breaking them into microservices. When you think about breaking down a monolithic application into microservices, smaller and smaller pieces, can your traditional AppSec scan those? You know, typically you would do your application security scanning near the end of your software development lifecycle, when you've done your unit tests, you've done some quality checks, and then you do your AppSec testing. Things to think about: if you're paying for that by the app, now you've got microservices. Are you going to, if you take one application and break it into 10, are you now paying for 10 applications that you're scanning? Those are things that you need to think through. The other challenge here is I mentioned people, processes, and people, processes, and technology. A lot of people are trying to align things by taking a security person and put them into the development team. There will always be more developers than there are security people. It's just kind of a fact of nature. And so if you're taking the approach that as a security team, you want to inspect all of the code, you want to be, security team wants to be the one to find the vulnerabilities, look at them, vet them, triage them back to the developers, you're going to be a bottleneck really quickly, especially in that microservices world and agile world where things are iterative and faster. The traditional AppSec is just not going to be able to keep up. So lead, follow, or get out of the way, as the saying goes. And I'm going to show you a way that I think the security team can lead here. You've got to rethink security, though. It's not a department, it's an outcome. And I love this quote from the CISO at VMware. This was from RSA in 2019. He said, your most important security product won't be a security product. And I absolutely believe that, because you've got to do things a little bit differently. People often get hung up on the scanning, though. Oh, I've got to find all the vulnerabilities. So I've got to have the best scanner that finds them all. And, the challenge that I would propose to you is, if you find 10,000 vulnerabilities, can you fix them all? If you find them and you don't fix them, now you've got a liability because you know that they're there. You've really got to focus on fixing what you find. So if you could fix what you find much earlier and empower the developer, then you're reducing your liability, you're creating a much more efficient process, and you're empowering the developers who are currently frustrated by the fact that they feel very responsible for vulnerabilities, but very encumbered. So it's not just finding them, it's fixing them and getting them to the people who can fix them, which typically is not the security person. The remediation has to happen with the developer. So how can you get those findings in the hands of the developer more quickly? If you think about it like a software factory, what if you dealt with each finding at the point where it's introduced? So if I'm a software factory and I'm, manufacturing cars, and I put the door on wrong, I'm not going to wait until the whole car is done and then send it back through the line to the door person to fix the door, right? I'm going to fix it right there. You need to think about your software factory in the same way. And security is just one of many types of flaws that are best dealt with at the point in which they're introduced. So the challenge becomes, how do you find them at that point, right? How do you find the vulnerabilities at the point where they're introduced? Well, if you embed your security scanning into your continuous integration process and automate it, that's thinking out of the box. That's doing it differently. And so think even more broadly about not just doing that with static testing, but doing it with containers and dependencies and license compliance and even dynamic testing. Now you might say, how do you do dynamic testing that early in the life cycle? It requires a running application. Well, if it's embedded within the CI process, the GitLab CI process spins up a review app, and we use that review app to run the dynamic test against, so that, again, before the code ever leaves the developer's hands, it's in that feature branch. And that's why, that's kind of the secret sauce here. So you've got your main branch, a developer checks out code from that repository and is going to make those code changes on their feature branch. If you can run all those application security tests on that feature branch before their code is merged back with everybody else's, the power that you get from that is this really tight feedback loop for the developer, where I made this code change and I created this vulnerability. So it wasn't Johnny 2 doors down that created the vulnerability. It's not something that's been lurking out there for 2 years and I just happened to step in it. I created that vulnerability. So I am best equipped to be the one to fix it while I'm still in my native workflow and I haven't checked it in with anybody else's code yet. So from a CI pipeline standpoint, this is kind of what it looks like. So I make my change, my code change, I commit my code, it kicks off this pipeline. I get not only my code quality scans, but all of my security scans. That review app spins up. The dynamic analysis happens against that review app, and I get my results. Now, as a developer, taking action here is also part of the key. So I see my vulnerability results, and I can take one of 3 actions. I can fix it. That would be ideal, right? I look at the material, the information and insight that I'm provided, and see how to fix it. And while I'm still iterating on, is my screen rendering like I want? Is it functioning like I want? I can take care of my security vulnerabilities at the same time. Now, let's say I can't fix it. Let's say it's going to take too long to fix. So I can, at that point, create an issue with a one click, automatically populates all the information about that issue. And that way I don't lose track of it, right? And make sure it's captured. Maybe I need to do it in another sprint. The third option would be to dismiss it. Now, when I say that the developer can dismiss a vulnerability, that always raises the hackles on the security people's necks, right? Oh my gosh, we don't want developers dismissing things. They'll dismiss everything. Well, that's not always the case. They might have legitimate reasons for dismissing a vulnerability. And if they document the reason, the really cool thing here is it's all captured. It doesn't go away. You can see it later, and I'll show you in a brief demo how. But it helps them set it aside, state their reason for setting it aside, and get back to focusing on developing their code. Now, when the security person sees it, so remember that feature branch, I've done my changes, I've done my iterations and taken care of my vulnerabilities that I can as a developer. I check that back in with my main branch, and now the residuals, if you will, the remaining vulnerabilities are going to show up on the security person's dashboard. So as a security person, I can see, what was dismissed, what remains, what issues have been created, and focus on the risk and focus earlier on that risk rather than waiting until the end of the life cycle. Now, the reason why this is so powerful is it's contextual, it's integrated. My favorite example for this, and in terms of analogies, is the cell phone. How many of you carry a real camera with you anymore? I mean, for day-to-day photography, you just don't do it. It might take superior pictures, just like, some of the scanners that have been around might find 10,000 vulnerabilities. But if it's not integrated where you can deal with those and take action on them easily, then it falls flat and you're just only solving half of the problem. So you've got these great pictures, but now it's on a flash drive and I need to find something that can read my flash drive, and it's not connected to the internet and all my social media. So, you know, if I take it on my pictures on my phone, I can immediately send it to my friends and family through a variety of different social media methods. And so if you can find the vulnerabilities in the developer's workflow and empower the developer to fix them, you're really solving the problem much more efficiently and effectively. Now, there's lots of other advantages of embedding your security within an end-to-end software development lifecycle platform, and that is visibility. So now I've got, I'm getting everybody on the same page. So my developers, my security people, my ops people, everybody's looking at the same picture. You're also taking advantage as a security person of the fact that GitLab is a leader in CI. So if you're kind of going with the flow there, if you can empower the developers using a tool that they already know and love, you're much more likely to get it used. I've heard of people that are having their developers use Fortify or Veracode or what have you, and those were really intended for security people, not for developers. And so that's kind of pushing a rope uphill. But if you can draft off of the momentum that the developers are already having around CI. Now, one other thing too that I should mention is the Gartner came out with a Magic Quadrant here recently for application security testing, and GitLab was the only non-AppSec vendor that was on there. Now, we were a niche, and the reason we're a niche is you probably wouldn't use us for application security testing if you weren't using GitLab for anything else. It just wouldn't make sense. But if you're using GitLab for source code management or for CI, it makes a lot of sense. So that's why it's a niche. It's for a targeted section of the market. So what if you could scan all of your code every time there's a code change, do it seamlessly for development using fewer tools, not more, getting everybody on the same page, and as icing on the cake, making your compliance auditors happy? Well, you can. I'm going to jump to a demo here real quick and show you a couple slides here on how you can do this and what it looks like. So let me set the context. This is a merge request pipeline. So you're in your CI, your pipeline report that comes out. So I've made my code commit, my pipeline's run. This is the result. This is the result of what I ran in my pipeline. And I can see here a summary of vulnerabilities that were detected. I also can see my license compliance violations. Wouldn't it be great to fix those too while I'm here? But let me expand. So SAST was clean, no new vulnerabilities detected. Now, new vulnerabilities is key here. Remember, I'm testing the diff, the code that changed. I'm not testing that entire application. So this is how I can run my scan very quickly and see the results in minutes, not hours or days, as some scanners take. Now, I can also see my dependency scanning, and it's sorted by the most critical at the top. The one that's been crossed out here, it's been dismissed. So it's still there. I can see it, but I can see that I probably don't need to look at it right now. Now, the security person might want to look at it later to see why I dismissed it and see if they agree with that. But as a developer, I don't need to be bothered with that one right now. So this helps me focus my effort. And then I've got my dynamic scanning, my container scanning. Now I can come over here and before I dig deeper on the dashboard side, let me show you what one of these looks like. Let's see. Let me show you one that's been dismissed here. So this is digging into that particular finding, and you can see that Kyle Mann dismissed this. When they dismissed it, you can actually pull up the pipeline and see what they looked at. You can have them add comments. That can be a requirement if you want. It's not set on here, but where they actually need to make a comment on why they dismissed it. And from here, I can create an issue. And if I do that, it's completely populated for me. So now the other really cool thing is, let's say an issue had been created. Let's see if I can find one where an issue has been created. Let's see. I'm going to go back here and expand my report. Well, if an issue had been created on this one, just like I saw who dismissed a vulnerability, I can see who created an issue and when. If, let's say, some time has gone by and that shows up on the dashboard, the security person can even see not only that an issue was created, but like you're looking at that current issue. Who's working on it? Has it been assigned a milestone? So you get all kinds of great insight and information here, whether you are the developer or the security person. Now this MR pipeline is intended for the developer. Now they can go look at, if I were to click here, I've already opened it here, but if I were to click the security and compliance tab, I'm going to get my dashboard view. This is for the project. So for the individual project, could be used by the developer, could be used by the security person, most likely used by like a senior person on the project that's wanting to know how that project's tracking. And it's telling me here, by the way, in, I guess it was May or June, this is June. So in May, we introduced standalone vulnerabilities, which allows you to do a lot more things, and it's just encouraging you to check that out. And you can export your dashboard into a CSV report where you can import that into a variety of spreadsheet, other tools, where have you. So we, in the spirit of playing well with others, we're trying to make it easier to do that. Now this is my dashboard for the project. So I can see for that project what vulnerabilities remain. And all of these I can see have been detected. I can sort or filter by my status. If I only wanted to see the ones that are dismissed, I can jump straight to those. Again, that's probably something that the security person will care more about, because the developer generally feels like, I've dealt with it, now I'm setting it aside. So a developer, I might not want to see those, but I might want to see just what's left. Or maybe I only want to see the critical ones. Now, this is the developer view. Let me show you the security view. Look familiar? So this is the group security dashboard. So you've got projects, and multiple projects make up a group. Multiple groups make up an instance. So there's also an instance level dashboard. The security person will generally care across projects. So they're going to want to look at the group level most likely. And this is a kind of a culmination of everything underneath that group in terms of vulnerabilities remaining. Now, like I said, look familiar? It should. And the cool thing here is if I dig in and I look at that individual vulnerability, I can see, again, it was dismissed, who did it, when it was done, the same information that the developer saw. So gets everybody really on the same page. You don't lose context and time switching between the AppSec program and your developer's program and trying to translate what's going on between the two different systems. Let's see. One other really cool thing about this is at the bottom here. Sorry, I just remembered they changed the UI here recently, so it's at the bottom. Is this risk view. So this is showing which projects do I need to focus on. We give them an A through F academic grading scale, and the Fs are the ones that are the worst. So those are the ones that you really need to look at. These projects, and this is kind of a summary that shows, wow, you've got some critical vulnerabilities. Look at this one, 26 criticals. And so that helps me as the security person really hone in on those projects that need the most help. So let me go back here and see if there's any Q&A. I was just going to finish. Oh, one other thing is I wrote a book on last year on 10 steps that every CISO should consider around cloud native applications. And so here's the link to that book. Feel free to have a copy. It goes into a lot of this in more detail in terms of thinking about cloud native applications and that infrastructure security, and how to get everybody on the same page. It's also available in the O'Reilly Learning Library. So with that, I think it's time for questions.
All right. Thank you very much for your presentation, Cindy. Yeah, I think we already have some questions in there, but of course as well, the hint for the audience, if you would like to give some input or have some questions for Cindy or the content she has just been presenting, feel free to have a look at the bottom of the panel and yeah, type in your questions in the chat or the Q&A field or tab. Thank you very much at this point. All right, I would say let's start off with the first question, which is security scans usually take a long time. Doesn't embedding them within your CI process slow down the whole development?
It doesn't if you embed it in the CI, because what you're scanning is the delta. So you're scanning that new code that was introduced, not the entire application. So instead of taking, hours or days to scan, it really only takes minutes. The challenge is, can your existing application security scanners do that? Some can, some can't. And so that's really the key.
All right, thank you very much. And the next question that I got here is, I saw that GitLab is a niche player in the Gartner Magic Quadrant. Are your scanners subpar?
No, they're not. As I mentioned, the reason for the niche player label is because of the market that we serve. So it has much less to do with the capabilities than the market. And we focus on GitLab users. If you were not using GitLab for source code management or for CI, it really wouldn't make sense, because you'd have to run a separate CI. Now you can, we've done a demonstration of how you can run GitLab scanning. If you're using Jenkins for CI, you can actually run a parallel process. So that's a possibility. And another kind of data point that I'll be writing a blog about here soon is we've done some efficacy studies about our scanners versus others. Now, under the covers for SaaS, we're using open source scanners. We automatically detect the language that's used and grab the appropriate scanner. And open source scanners have a whole community behind them, making them better. And you'll be pleasantly surprised with our Java scanner in terms of the results. We have less false positives and more true positives. And so it has nothing to do with the scanning. It just has to do with the market that we focus on.
Mm-hmm. Thank you very much. There's one question. I think you mentioned it during the presentation, but maybe it's worth repeating as the question just came in. How can application security become iterative, automated, and embedded? Maybe you can go into detail there and give some hints. I think this is something that you kind of mentioned in the presentation, but maybe the person also tuned in late.
Right. Yeah, it's all about focusing on the developer. So empower the developer to find and fix the vulnerabilities. And the way to do that is to deliver those scanner findings to the developer within their CI pipeline. So put it in with GitLab, it's in the merge request pipeline. All of the different types of scanning results are there, and they're very highly actionable. So they can take action while it's fresh on their mind and they're still working on the code.
Mm-hmm. Thank you. The next question would be, who's actually, or how, well, I think it's written a bit weird, but who's actually taking responsibility doing the scans, or how would you separate the responsibility of the developer and the security guy in this case? Who's
Sure.
doing what?
Yeah, well, this doesn't diminish the importance of the security person. What it does is it helps you scale your AppSec program. So the security team really becomes responsible for setting the policies. So for instance, your policies reflect your appetite for risk. As a company, am I comfortable? Is this company comfortable moving a vulnerability into production? Maybe so. Some are, some are not. So if not, though, then one of the policies would be to fail the build at some point if there's maybe a critical vulnerability finding. It's those kinds of policies that the security team sets, administers them in the tool, and then the tool automates that for all of the developers to use. So security then can focus on what policies are working and which are not. Because here's a thought. Maybe my policy is to fail the build for any critical and high severity findings. But maybe in reality, since I'm not currently automated, I'm getting exceptions for all of those. And so everybody's working around those. And when I automate it, oh my gosh, everything's failing. Well, if you've automated it and they're being applied more consistently, then maybe your policy's too tight. If everybody's granting exceptions and you just didn't even know that they were granting exceptions. And so it helps you see what's going on and tune it and focus on the process a little bit more and the policies and assess drift from your policies. And so you can take on much more meaningful tasks and impactful tasks rather than simply focusing on triaging. If you find 10,000 vulnerabilities and somebody's got to triage them and then follow up with development and make sure that they actually fix them. So it's a matter of changing where you're applying your time.
Definitely makes sense. Thank you very much. I think one more question I got now, which is, what would you say, also based on your experience, are developers aware or taking this whole thing serious with security and risk? What is your experience with the developers? Do we have to kind of train them, or are they actually using the tools to, compromise or not compromise security and risk when they're developing applications?
Yeah, the key there is putting it into their hands in the context of the tools that they're using. That's part of it. And then also not being so academic about the findings that you need a PhD to interpret them and figure them out, right? And so you really need to empower that developer. I did a focus group, and they really want to do the right thing. And I asked them, is it a carrot or a stick that is incenting you the most? And what I found is no one wants to be that person, air quotes here, that person that brought their company down. They take that responsibility to heart and really seriously. So if you can embrace the fact that they really do care about writing secure code and just make it easier for them to do that. So putting it into their workflow, putting it into their context, making it very actionable. If they can click, an issue button and fire off an issue so that it doesn't get forgotten, those things are very, very powerful.
All right. So thank you very much. I think that's all the questions that I have for now. So thanks again for holding the presentation and for giving detailed answers on all the questions and for being here, Cindy. Thanks again.
Thank you.
All
Take
right.
care.
Take care. Bye-bye.